Okay, so it seems we have the majority already. Good morning. I hope you had a good night's rest and sleep. So for today's activity, where's that thing that I typed a while back? Yeah. Is it still visible in the chat box? I lost it already. Okay, so as indicated in the agenda, first I'll be talking a little bit about a recap of what has transpired in our class yesterday. And thereafter, you'll be led to your breakout rooms to discuss whatever findings or things that you were able to find out using the sorting algorithm that was assigned to you. And then um, once you go back to the main room, someone should already be assigned to do the presentation. Okay? So you could present in any manner as long as the important thing is um, you would learn how to use the algorithm and how to simulate it given a specific data. Okay, we're good? Okay, so yesterday, I do hope that the sessions were not so um, difficult for you. I know you had fun in the afternoon session with the games design class. Yeah, we all had fun there. So now we go back to a little bit of serious stuff. Okay, so what you've learned yesterday was practically the basic of learning how to create programs. So you've learned that in order for you to be able to create programs, you have to devise an algorithm first. And we've defined an algorithm to be what? A set of instructions, a finite set of instructions, that is. The word finite is very important because when you start designing or creating algorithms, it should stop at a certain point in time. Okay, you don't create algorithms that runs forever or executes forever. Okay, there should always be a terminating process. Okay, and in solving problems, once you're given a problem, you have to know what your input is and what your output or outputs are. Thereafter, you could be able to devise steps on how to solve that given problem. Okay, and you were able to learn as well that you could be able to create and write algorithms using any language of your choice. You could write an algorithm based on your dialect, for example, right? Or you could write it in English, or you could write it in pseudocode, or what we call as quasi-English yesterday. And you could also show them using flowcharts, right? Okay, so I guess with that, that's pretty much what we were able to cover yesterday. Right? Agree? Okay, so now I guess you're given 30 minutes to discuss with your groups, okay? And then thereafter, you come back to the main room. Then we start with the presentation. Starting off, yeah, we just go chronological order lah. CS Group 1 up to CS Group 9. Each one is allowed to present up to 10 minutes. If you could do it in 5, much better. Okay? Cool? Right. So let's go.
So I will open the breakout room, yeah. So if you haven't get the invitation, it means I haven't assigned you to any room, yeah.
Do they have to like make a presentation or something?
No need. You just need to discuss lah.
Discuss about their understanding of the sorting, right?
Yep.
All
And,
right. Okay.
in doing so, you have to show simulation or something.
Okay. Okay. All right.
Were
Thank you.
you? Were you? Are you from the breakout room already, or?
Yeah. I was from the breakout room. Yeah.
So you went back to the
Yeah.
main room already. Okay.
All right. Thank you,
So
sir.
let's just wait for the others. There'll be like one representative per group to present anyway.
No, my group said there will be like all of them are presenting together.
Ah, okay. Gapapala.
All right. So simulation as in like a code running, right?
No, it's not the code, but It's more of like a screenshot or a video or something,
All
or
right,
maybe
okay, okay.
animation. It's
Just
totally
like
up.
how the selection sorting visually works. Good, all right.
Yes,
All right,
yes.
all right. Thank you, sir.
You're welcome. Okay, so may we know who are the presenters for each group? You could just type it on the chat box so that you would be able to like share your screen. We could make you a co-host. Where's your audio?
Here, sir.
Okay,
Sorry.
no problem.
So, hello everyone from the CS class. I'm Jonathan, and I'll be presenting with my partner Fabio.
Where's your
If
camera? No
oh,
camera?
oh
So
yeah,
shy?
sorry.
Okay.
So there are a lot of sort methods that I have researched, and they and for different processes they all end up with the same result. For the ones that we're presenting now, it's about insertion sort.
Okay.
Wait, give me a second. Okay. So an insertion sort is a simple sorting algorithm working similarly to the way you sort of playing cards. So how does it work? The pile is sorted into a sorted and unsorted part. Values from the unsorted part are picked and placed at the correct position in the sorted part. So basically, we start from one value, which is the initial index in the array, the first element in the array, and then it compares with the second value, and then it be classified as a sorted value, and then the remainder, which is not sorted, is classified as the unsorted value. That's how I interpret it. So
Okay.
as the process continues, each of the sorted values will be compared to the unsorted value, to the one unsorted value, one by one, and then they will compare each of the sorted values with the unsorted values, and then if they met their certain conditions, whether if it is ascending or descending order, it will shift it to the it will shift it it will shift the numbers, yeah, to the right.
Okay.
That's how we interpret it. So this is one of the examples. So as you can see here, for the first index will be 4. It will compare it with 3, with the second index, which is 3. Um, since 3 is greater than 3 is less than 4, the index will switch, and then it will become like a classified as a sorted value. I mostly think of this as a game, like the caterpillar game, where you play rock paper scissors, and then like if you lose, you have to go to the back of the person, like to like if you lose, like you have to go to the back of the person, like, and the winner will win if you have the most people in the back, something like that.
Okay.
And so the sorted values will be compared to the next value, which is next to them, which is like 2 in this example. And then like since 4 is greater than 2, it will shift to the left. And since 2 is greater than 3, it will shift again to the left, which will make 2 the first which will make 2 the first index.
All
And
right.
then the process will keep continuing. For example, 10. What happens if it is greater? It will stay. If this is greater than all these numbers, it will stay put. It will just stay there. But however, if it is greater than one of them, it will shift.
Cool.
Then all of these numbers, it will stay put. For 1, since it's greater than all of these numbers, it will shift all the way to index number 1. For 5, the next example is number 5, which is greater than 4, 3, 2, and 1. However, it's smaller than 10 and 12, which means it will shift only in 2 places. And also for 6, it will shift since it's greater than 5, 4, 3, 2, 1. but smaller than 10 and 12, it will move 2 places. And there we go. We have the sorted array. And
Okay.
yeah, and so this is the flow chart. This is the process of how they make the insertion sort. To be honest, I'm still like a bit confused on how it works, but I'll just try to explain like the ones that I understand.
Yeah, no problem.
So basically it starts with the length of the array, which is n, which is initialized as n, and then we initialize the array index, and then like we initialize the array index, which is set I as 1, and the set value array is equals to set array and index 1, and then we set the second variable, which is j, which is I minus 1. And then we need to like ask if j is greater or equal to 0, or the value in the index of j is greater than the value next to it. And then if it is yes, it will do this. It will swap with each other, and it will decrease. The j will decrease by using the decrement. Using decrement. If no, it will stay in that value. It will stay in the same index.
Yep.
And then I will increase. And if I is lesser than n, it will If no, it will be sorted array. Okay, I'm a bit confused about that.
Yeah, it seems you well understood the flow chart, so no problem.
Yeah. So this is the implementation, the deck of cards, sorting the deck of cards in order. So like, if for example you have like 5 cards that are not in order, you wanna start from for example you have like in the first index in the 0 index, since array start from index 0, we start with 10 of spades, and then like the first index will be like 5 of hearts, and then the second index will be like jack of diamonds. Like for example, three of these cards are in your hand. We compare them using the insertion method for it to be 5 hearts as the first value. The second value will be 10 of spades, and the third will be jack of diamonds. That's how we implement it.
Okay, thanks.
And this is the simulation that we have for you guys. Like this is like the example if you don't really understand what I'm saying.
Okay, thank you very much, Jonathan. Are there any questions from the other groups, or did Jonathan give justice to his discussion using the insertion sort? Okay, no comments, so we move on to the next one. Thank you.
Yeah, thank you, sir.
Yep. Okay, next, CS2. Who is in charge of CS2?
Me.
Okay. Marvel, right?
What?
Okay.
Okay, hold on. Made a very simple presentation. Is this on full screen? Hello?
Yep.
Okay. So here are from CS2. Here are the names of our members. We will be presenting section sort, but we're going to do it as simple as possible because we don't actually know it that detailed. So
Okay.
this is, Okay, so the basic definition of selection sort is basically a simple sorting algorithm algorithm. So if you want to put it simply, if you have a set of numbers or elements, so you will have a left side and the right side. At the start, your left side would be empty and your right side would be filled with the elements that hasn't been sorted out. And the element from the right side would be sorted out and would be moved to the left side. And if it has been moved to the left side, and the number would be already sorted out. And how do they sort them out? Is they swap the smallest element. They first locked into the first number and try to find a smaller number in the next element. And if they found something smaller than what they first locked on, they will swap it, exchange it to the front row, which is the left side, and that one that has been swapped will be swapped to the back. And it will keep repeating that process until all elements are sorted. And Fania will continue a bit. Fania?
So the algorithm is not suitable for large datasets, as its average and worst case complexities are of O n squared, where n is the number of items. And O is big O notation is used in computer science to describe the performance or complexity of an algorithm and describe the worst case scenario. So it's not compatible for large sets of data.
Yep.
Right, okay.
So you've also researched about big O notation, yeah? That's the worst case.
That's the worst case.
Okay.
And for visualization, we are using this link, which leads to my Google Chrome. Is this available?
We cannot see your Google Chrome.
Okay,
So
hold
maybe
on.
stop sharing PowerPoint and share Chrome.
Okay. Okay. And
Yep.
there you can see. Okay, Leon will explain this. Leon, are you ready?
Yeah.
Okay.
So as you can see there, the red is the unsorted side, and the blue is the red is the green is the one that you are checking at the moment. At the moment you are checking, and then you swap it with the red side. And then after that, if you are done with the partition, you continue to the second, and you plus the final. So you start not from the beginning again, but you start from the second, and then you start from the third index in the array, and then you start from the fourth index in the array, and so on and so forth.
Nice.
Yeah, I think you can see there. And the way that you search for the minimum is that you update as you find a smaller element. So for example, you set a temporary variable there, and then after you set the temporary variable, see if the is variable, then you set the temporary variable to the check element. I think that's all, and we can see the animation there. Okay. We can see that 15 is the minimum unsorted there, 26, and then 19 is less than 26, so we update the value here. So we swap it there, and so on and so forth. Okay.
Okay, with that, we shall continue to our presentation again. All right. And then this is the visualization I've done with Leon. Then this is the algorithm, will be by Tanya.
In the algorithm, the first step is to set the minimal location to 0. The second step is to search the minimum element in the list. And the third step is to swap with value at the minimum location. The fourth step is increment minimum 2 points to next element. The fifth step is repeat until the list is finally sorted.
Okay, with that being in mind, last but not least, we have the pseudocode would be explained by Jason.
Okay, so very much this is the pseudocode. In the pseudocode, there's two main variables, which is the list or the array of items, and n, which is the size of the list or array length. So very much in the pseudocode, we're going to use two for loops, one for checking the whole list and one for checking in between each index. So when the first loop goes, it would set its minimum at the first one, and it would find a smaller number in the next index of the list. And then when they found the smallest number in the list, they would swap it to the first one. And then it would exit that second loop to the first one and do it again. But instead of the minimum in the first index, it would start at the second index instead, and it would repeat back again until the whole list is sorted.
Okay.
And with that, we say thank you for hearing our presentation.
Okay, thank you very much, CS2. Well explained and well discussed, even showing a simulation. Any questions from the other students? All good? We give them a pass? Right. Okay, CS3. May
Hello,
start?
my name is Aleph, and I am from CS4. I'm the representative for CS4, and today we're going to present about merge sort. So basically, let's start with like, what is merge sort? So basically, merge sort is like it's a sorting method, of course. It's like it's recursive, so basically, it's a method that calls itself, and it's basically how it's the principle. It's a divide and conquer method. So basically, you divide. So basically, it works like you divide everything until like you can't divide anymore, and then you just recombine it again. So basically, yeah, that's how it works. So, and it's a very efficient sorting method for like larger data sets. And so basically, merge sort does like log n merges steps because each merge step doubles in size. So basically, where n is equal to like the number of items in the list. So basically, say there's like 8 items in the list. So log 8 base 2 equals 3. So basically, since you start with like 1 item per list, so basically, and then you get 2 items, 4 items, and then until you get 8 items, basically. And then as a result, it takes like 3 merge steps. So you're gonna see in like in our example, there's gonna be 8 items in the list, and you're gonna see there's like 3 merge steps basically. Oh, so basically this is the algorithm. So basically, step 1, if there's only 1 element in a list, it's already sorted because you can't really divide 1 element. So yeah, so if there's only 1 element in the list, you're done. Step 2, so basically you need to divide the list into 2 halves until it can no longer be divided. And then the third step is basically you merge the smaller lists into like the new list with like a sorted order. You'll see how it works basically when you go to like the flow chart. So basically this is the flow chart. So here, this is the example. So this is our list of elements. So basically we divided the array by half, and then it'll look like this. So basically when you divide the array, you don't actually change the order. You just keep it the same as it is. You're gonna change the order once you go like the conquer section of this sorting method. And then you just keep going, and so on and so forth, and yep. Until you end up with only like 1 item, and you can't really divide it anymore. So basically, the end product of the divide process will look like this. and so this, so this is what it looks like. So basically, when you combine this, when you combine these, you slowly combine it. So like the same way you divide it, but instead you actually have to like arrange it sequentially. So basically like this one, the one that's circled. So basically there's 27 and 10. So because it's sequential, basically 10 goes first, then you go 27, and also same like here, and becomes like this. And basically you keep doing this process until you end up with this. So basically this is the same data set, but it's in the sequential order. And that's basically the merging sorting.
Nice.
Yeah, that's it.
You're done?
Yeah.
That's it?
Yep.
Where's the pseudocode? No pseudocode?
Oh, I had the pseudocode, but it's actually quite long, and it's
okay. Yeah, but at least the concept of how merge sort is it clear to everyone? But here you have to study how recursion works. Okay? So that's why I was asking for the pseudocode, but I guess it's too early to ask for that one. You'll be learning more of those algorithms once you reach what? Analysis of algorithms or data structures. Okay, thank you very much, CS4. Well done.
Okay, so for my group, we did. So essentially what we found out was that if we wanted to do quick sort, normally we would pick a pivot from the table above. For example,
could you share screen
here, what?
Okay, yep. You start from step one.
Normally they would pick number of edge of the table. For example, here I picked 7. So that becomes our pivot. So anything less than or equal to 7 will go to the left side, or anything greater than 7 will go to the right side. Hello?
Yeah, I guess we're losing Darren again. He's still presenting, but his audio is gone. Darren?
Yeah, hello.
Yeah, we lost your audio a while back. Oops.
Sorry, I think there's something wrong with the Wi-Fi as well because of the blackout just now.
Okay.
So essentially, after getting the pivot, we will separate them into 2 sides. On the left side, we will have numbers that are equal to or less than 7. And on the right side, we will have numbers that are bigger than 7. After that, if it's still not sorted yet, we can make extra pivots. For example, here I chose 4 for the left side and 9 for the right side. I named them as pivot A and B. So following the same concept from the first pivot, we will put the smaller number than 4 to the left side and the one bigger than 4 to the right side. Essentially, we repeat the process from step 1. After that, we bring them. We combine the 3 pivots together to get the sorted list, the sorted table. That's pretty much it.
Okay. And then?
Yeah, that's pretty much it, sir. It's already sorted.
Okay. Well done. Could you show us pseudocode if you have it?
We had one, but then I think it's too difficult, so we decided not to use it.
Okay. But the concept here is like you have to choose a pivot first, any number from the list, right?
Yeah, but normally what I found out was that they would normally pick the numbers at the beginning of the table or the back of the table.
Okay.
Because it will make it easy.
Yep. Okay, thank you. So,
Thank you.
is it good? All good? Thanks, Dar. So we now move on to like what? CS5? Right.
Yes, hello, sir.
Who's at CS5? CS5 looks like CSGO, yeah? All right, Marvel's turn.
Yo, Nathaniel.
The
Are you
otaku's
there?
over here.
Yes, I'm here. Why?
Ah, okay.
Okay, may start?
Okay. So we made a video about this one.
Heap sort.
Okay, let's start. Yeah.
From what meat cafe did you pick her up? No audio for the video? All right.
Okay.
That?
Something like that.
Okay.
So here I made the pseudocode, if you can see it. For, Is it this
Yeah,
one?
we can see it.
Yeah. Previously in the video, it was pseudocode for parent with index 1, and this one is we start with index 0.
Okay. Yeah, the what do you call this one? The catch with this type of sort is you have to learn the concept of a heap first, right? So if you don't know what a heap is, then it's pretty difficult to visualize it, right? Because if you're gonna look at the heap, it looks like a tree. But what makes up a heap? Maybe you have to tell us what a heap is first. Marvel, did you do the research on what a heap is?
All right.
Hey, One Piece guy. Yeah, maybe a definition of a heap would actually be okay. You go to all rather than in the images. Yeah.
Okay. All right.
Okay. But yeah, this time you have to know what a binary tree is, right?
Yes.
Because a heap is a type of a binary tree. It's called a complete binary tree. So, oh man, this will be a lot of things worth discussion. However, the main concern here is, okay, we'd like to know the algorithm, and you showed us the pseudocode, and a little bit of simulation perhaps. But yeah, it's okay lah. No problem.
Simulation. Right. Maybe. Is there still time, sir?
Yeah, there's still time. Oh wait, it's already 10:30.
Oops.
Okay, no problem lah. We'll make time next time, right?
Okay.
We could make time next time. Cool video though.
Thank you, sir.
Thank you very much. So now we could go to CS what? 6?
Hold on, sir. Let me share my screen.
Yeah, I mean, from all of the algorithms that you're actually going to read about, yeah, the heap is a little bit different because it made use of the concept of a tree. So you have to learn what a tree is first, and then you have to learn what a binary tree is, and then you have to know what a binary search tree is. Then you have like AVL search trees, then you have heaps and those things. Okay? So, yep, CS6.
Okay, sir. Fadlan,
Okay.
you may start speaking.
We're losing you.
Hello? Can you hear me?
Yep.
Hello?
Yep.
Okay, so we're gonna start with Fadlan.
Okay. Can everybody hear me? Hello?
Yeah, we can hear you.
Okay, right, sure. So we are from CS6. We are going to be explaining about insertion sort. It is a sorting algorithm method. And to explain insertion sort, can you open up the image, please?
Wait, hold on. Can you see it?
Yes. To explain it simply, a insertion sorting method is just like having the list and then separating and then the rest of the unsorted part. So in this example, we are going to set the first number from the list, 9, as the sorted one because there's nothing to compare it to. But then we are going to compare the next number to the sorted list. So now we are comparing 7 to the 9. Since 7 is lower than the value of 9, it's going to be put to before the 9. So it's going to be 7, 9. This is the new sorted part of the list. And then we are going to be comparing the next unsorted part to both of the numbers in the sorted part. So the 6 here, we are going to first compare it by 9. Oh, 9 is greater than 6, so it's going to be put behind 9. But then we compare it also to the first number of the list. Is 6 greater than 7? No. So it's going to be put before the 7. So the sorted list now becomes 6, 7, and 9. And then this process are going to continue to the next number, to the next number, to the next number, until it goes to the last number of the list. So in this case, we're going to be skipping off the part and we'll go straight to the 11, the number 11 here. It's going to be comparing it to 17, to 15, to 10, etc. And then it's going to be the finished list, which is 5, 6, 7, 9, 10, 11, 15, 17. And that is the insertion sorting method.
Okay, next I'm gonna show you the flow chart. Hold on. So here is the flow chart. So we start, and then we had a while. This while, as long as we haven't reached the beginning, and there is an element in our sorted array larger than the one that we're trying to insert, that element moves to the right. So here is the example of move to the right in the array position. And then if everything is sorted, then we'll go to the print array element, and then we stop. I'm gonna show you the Python script for this thing. Hold on. Can you see my screen? Can anyone see my screen? Hello?
Yep.
So in here we got for I in range the length of the array. it is 2 transfers from 0 to the length of the element. You can use fixed number if you know the amount of data in your array. Like maybe in here we got 1, 2, 3, 4, 5, 6, 7. You can put 7 in here. Then we got j equals I minus 1. It is to move the number that is selected into the left side until it meets the condition, that is if it's less or larger to the sorted part of the elements. And then there is inserting the elements here. And there is the print thing. I'm not sure. I'm kind of sleepy last night. Okay, so if we run this script, wait, hold on.
You should use range. Okay.
Then it is sorted. Okay, so that's it for us. Thank you.
Bentley, your audio.
Yes.
Okay. You're presenting? Of course not.
Hello, everyone. Can you hear me?
Yep.
Okay, so I'm Ariel from CS7, and I'm going to be presenting selection sort. Okay. So, well, this is basically how you visualize it. Okay, we have a jumbled array in the beginning, 42, 16, 84, 12, 77, 26, and 53. Those are not sorted, right? So how you sort it is basically you set the first number in the array, the first value, as the minimum for now, and we check throughout the list if there's a smaller number than the current minimum. So okay, the next number is 16. That is smaller than the minimum, so we'll set that as the minimum for now. 16 right now is the minimum. We move on. 84, not the minimum. 12, oh, 12 is smaller than the current minimum, which is 16. So now 12 becomes the new minimum. Okay, 77, nope. 26, nope. 53, not quite. So what you do now is that you swap the first value, 42, with the new minimum that we found, which is 12. So yeah, 12 and 42 get swapped. Okay, and then we just keep doing the same thing again. Now 16 is the predetermined minimum, and we go check to see if there's anything else in the array that is less than 16, the current minimum. 64, nope. 42, nope. 77, 26, 53. Okay, none of these are lower than 16, right? So we don't do anything here. 16 is the current minimum, and now two numbers are sorted. And then we just do the same thing again. 26 is the new minimum, so we swap 26 with 84, and then so on and so forth until we reach the end and everything is sorted. Okay, so this is the flow chart. You basically start, you read the array in N, the length of the array in N, array in R, set I to 0, and you do a check to see if there isn't actually a list to go for. Because if I is less than N minus 1, that means it's already sorted. So we go through, set the minimum index to I. I is the first number, so the minimum is set to I for now. And then J will be the thing that scans through the array from 2 to 3, 4, 5, 6, 7, so on and so forth. And now we have a loop here. Is J less than N? Because yeah, is there like a thing there? And is J array J less than array min index? This is the check to see if J is less than the current minimum. And if it is, then the minimum index then becomes J. And then you add, and then you keep adding a value to J, and then J basically moves up the list to see if there's anything smaller than the minimum. And when it's done, it swaps the minimum that J found and swaps it with R. and then you add I, and it goes on. This is the pseudocode. I'm not 100%. I don't get it yet 100%, but I get the gist of it, kind of.
That's enough. It's okay.
Yeah. It's basically kind of like the flowchart that I told you earlier. Yeah, that's about it.
Okay. Thank you very much. CS7. Well done. 8. Oops, wait. There's a question here. Is end similar to break? Depends actually. If it was a pseudocode, you could look at it as the same. The difference between end and break is, let's say, for example, a loop is currently running and a certain condition is met. Then you issue a break statement that it actually terminates the loop and goes to the next instruction. End is different because that marks the end of a certain block. And then most likely it's the block, depending on the block, where the end has been defined. So if the block was defined inside the loop, for example, then you just end the loop. If the end was defined in the main program, then you have to end the main program. But since we're just talking about algorithms and stuff, you could actually look at the end and the break as, yeah, a little bit similar in function. Okay? But if in programming sense, they're totally different. Both are different. Right? Okay, CS8. Rafael, okay, this moment. Okay, Raf, you're on.
Okay, hello, sir. One moment. Okay.
Okay, another look at quicksort. So we get to have another look at quicksort.
All right. Okay. So, hello everyone. I'm Rafael from CS8, and Morris and I today we'll be explaining a bit about quicksort. So, a bit about the background. Just there's some irrelevant information here, but so basically it's developed by British computer scientist named Tony Hoare, published in 1961. It's similar to like the merge sort, where it's a divide and conquer algorithm, and it's based around a element as a pivot, and this element is basically a variable. Can be a number, can be anything basically. So the process is that first we pick a pivot point, and then the important process, which is the partition. All the elements that has a value of less than the pivot point will be moved to the left, and then all the values that are above the pivot point will be moved to the above the pivot point, and then recursion happens, and yeah, it keeps going and going. So yeah.
Okay, so this is the pseudocode. It looks difficult, and it is kind of difficult, but I think I get it. I think.
Okay.
If I'm wrong, I'm sorry.
There's nothing to be sorry about. You're forgiven. Semester 1.
This is the partition function. This is what's used to sort the pivot into its correct position. And so you see here, it takes the array, the lowest index and the highest index as the parameters. The pivot, in this case, is the element on the rightmost side. There are some other cases where it's in like the middle or the very left, but in this case, it's on the very right. So I here, the variable I, is used to determine where the pivot will be sorted into later, if that makes sense. And J is used to compare if the, okay, hold on, let's get into the loop first, okay?
Yep.
So for j equals to low, so it starts on the very left side until high minus one, because high is where the pivot is. If the element in that in the j index is smaller than the pivot, you increment I, and you swap the element in I with the element in j. Okay, and then you do this multiple times until in the end you swap the pivot with I plus one because the element in I is smaller than the pivot. Yeah, and in the end you return the index of the pivot.
Well,
yeah, yeah. It's hard to understand, like.
Yeah, at least you get the picture. A while back when they discussed the what's this sorting algorithm again? Merge sort, right?
Oh, merge sort.
Yep. So they didn't show us the pseudocode. However, they showed us a pictorial representation of how it works. So
yeah, we'll show that later.
Yeah,
at
we
least
have,
now we know what's happening when they're partitioning, right?
Yeah,
so
yeah.
It's actually sorting while it is partitioning, so that when it puts it back together,
yeah,
the list is already sorted. Okay, cool.
Okay, next. The next one is the recursion.
Okay.
You see here the if conditional inside is the base case. This is the condition that ends the recursion. If there's no base case, it just keeps going forever, and you don't want that.
Yep. Definitely.
This variable pi stands for pivot, but it's not actually the pivot. It's the index of the pivot, and this is so the previous function, it returns the value of the index of the pivot, and it puts it in this variable. And below that is the general case, which which is where the recursion happens. So in this one, it does the left side first, and then when that's all done, it goes to the right side, and it sorts it all off. The base case, the condition here is if low is less than high, it still continues. What this means is that if low is equal to high, which means, well, there's only one element, it stops. And when it all finishes, it's sorted.
Okay.
I hope that helps.
Here's a visualization, right? So the array here, we're given, right, these numbers. They're not in order, right? And so we define that 70 is the partition or the pivot of this array. And then later it sorts it out so that like the numbers below 70 or lower in value of 70, yeah, they sort it out like this, right? So 10, 30, 40, 50, it in order. And then later partitions around 50 for and then yeah, so on and so forth. And then later after that, it partitions. Here's what happens if the pivot is less than. Sorry, if the numbers are above the pivot. So like 80 and 90 and whatnot. And then there we have this, yeah, kind of like the whole array in lowest value to highest value. We have a visualization. Sorry, a simulation. Oh, whoops. Here. So here's a visualization of quicksort. Hold on. What's going on? Sorry. Okay. So this is bubble. So
are you doing quick or are you doing merge?
Quick, sorry. So here, right, it shows 3. That was the partition. Now it's 38, and it's yeah, it's assessing these numbers. I mean the values, and according to how low and how high it is compared to the pivot, and so on and so forth. So the yellow is the pivot point, and then it groups based on that. Yep. And so there's the final the final result, right? Yeah. And
okay.
Moving on. Okay. Okay.
Okay, so optimization. Apparently, they used to have the leftmost element as the pivot point a long time ago when it's still new. But apparently it will result in the worst case scenario when it's used on already sorted arrays. I don't really get why, and to be honest, I didn't really look into it because I was too busy trying to study the pseudocode.
Okay.
But yeah, they fixed this by using the middle index or rightmost index.
Okay. So it's either the middle or the rightmost.
It could be others as well. I know there were a ton of variations that I've seen on Wikipedia, and I obviously didn't have time to look through all of it.
No problem. Nice. Well done.
Yeah. So that's it.
There are also some which has two pivots inside. I don't. Okay, never mind. Yeah, just.
Okay. Yeah, you will be discussing more of this in analysis of algorithms class.
Yeah.
Okay. Thank you very much. Now we move on to the last group, CS9. Oh no, it's already 10:50. You still want to listen to CS9? Yeah lah. Okay. Jason, doing the merge sort.
All right, so CS9 will be doing merge sort.
It was developed by John von Neumann in 1945. And like one of the funny things is that he's far more interested at the sorting method because he did a lot of stuff. He did hydrogen bomb, he did fluid dynamics, and he found game theory and mathematics as well. So he's a very, very interesting, fascinating guy, I'll say. So he did a lot of things.
All right, so how merge sort works, I think it's already kind of explained from the previous group. So we take an array of unsorted numbers. After that, the array will get halved repeatedly until it cannot be divided again. So for example, from 8 to 4 to 2 and to 1. After that, the broken down array will get rearranged, and then it's gonna be sorted again to a new array that's already sorted out.
This is the pseudocode for the algorithm. Oh, I mean for the merge sort. As previously explained by CS3, it uses, or CS4, it uses a recursion. For those who don't know, a recursion is where a function calls itself within the function. So basically, you create a function, and then you put the function inside of the function. It is not entirely true, but it is more or less a substitute for a loop. Here in the second line is the exit condition for the recursion. So when the size of the length of the array is 1, it will stop dividing. Or if it's not 1, it will be split. Here, split line 5 and 6, it splits the array into half, the left index and the right index. The left index is the first one until the middle, and the right index is from the middle to the end of the array. And then here, below that, is where the recursion happens. We use the recursion on the new array that we have created. And then we use another pseudocode for merge, which will be explained.
Okay, so once it is separated, the 38 right here becomes the left subarray, and the 27 becomes the right subarray. And we make a new array, which is array 3 here, in merge, in the merge function. And what we do is we run and compare each array and make sure that it is merged again. But once it is merged, it is already sorted at the same time. So that's where the efficiency comes, because it can sort while it is being merged together before dividing the next before resuming the next function. Because when the recursion happens, when it splits down, it pauses the previous function, and once the recursion is done, it will resume the previous function so that it can go to the right sub of the root of the array. So here what it does is it checks if the array is, if the first index of the array 1 and the first index of the array 2 is, which one is bigger, and the smaller one will be appended, which means it will be just inserted into array 3, and then once one of the array has no value, it will check which array has which array still has value and just append everything into the new array. As we can see here, 27 and 38, 27 is smaller, so 27 is merged into this array number 3 right here below. And because array 1 has 1 value left, it automatically merged it next to 27. So once this is done, it will return array 3 to the previous function.
Nice.
Okay. When it is returned here, it will then so it will then run the right sub one, which is the split 2 merge sort split 2. So it will go back up to the second one, which is 38, 27, 43, and 3, and it will separate the 43 and 3 into another array, and then it will run the split 2 again. The split 1 again, and it will split to the left one, which is the 43 right here, and the 3. So now split 1 is 43 and split 2 is 3. It's both an array, but it has only one value. And then it will go back to the merge function, and it will rerun all the whole merging of the 3 and the 4, of the 3 and the 43. And after that, it will rerun merging the split 1 array and the split 2 array. In this case, the split 1 array is 27 and 38, and the split 2 array contains 3 and 43. So now it goes to the while loop, and it compares 27 and 3, which is the first index of both array, and then it takes the smaller value, which is 3, and append it inside the array number 3. So, and then it compares 27 to 43, because now 3 is out of the picture. So 27 and 43, 27 is bigger, so you append the 27 into the array 3. And then you compare again 38 and 43. 38 is smaller, and then you go out of that while loop and you continue on to the next while loop. And because length of array 1 is not bigger than 0, it goes on to the next while loop, and it checks if, and it just checks if the array 2 has value, and it has value. So 43 will be appended to the array number 3, and it will return the array number 3. And in this case, it will go back up and do it all over again in the right sub tree. And when we do that, we will get the sorted value in the last one. I don't know if that explains, but I hope
definitely.
enough.
Okay, thank you very much, everyone. Impressive work. Given you only have to look into
sorry,
this
sir, there's more, sir.
like what, since yesterday until today. You did a very fine job, very impressive. You all get A's today.
Also,
thank you very much.
Count it.
Huh?
We don't count it.
Yeah, but they get an A for today.
Okay.
Tomorrow is another day. Okay, so with that, I guess we're done for our session. You could already jump to the next session with Bayu and Pa Raymond Bahana.